Today I'd like to demonstrate how to install a virtualization server, otherwise known as a homelab. This will serve VMs on addresses in our LAN. If it sounds like this is common knowledge, it probably is, in that this is what ProxMox has been doing for years. I'll be approaching this with a dev perspective, whereas a single-purpose tool like ProxMox is more intended for sysadmin use. I haven't tried ProxMox myself. I need a regular Linux distribution to host this hypervisor. What I need is for my laptop to default to not running virtualized. I want unrestricted access to the hardware when I log on, not to have to go through ProxMox. Devs aren't expected to run ProxMox as their daily driver. Outliers won't be supported. If I need to configure my laptop with a script my team uses, I don't want to go it alone because no one else is using a niche operating system / hypervisor. So I'm going to be installing Ubuntu on bare metal. I've already done this procedure with Ubuntu desktop. There is just one small difference between desktop and server. The difference is the location of the netplan configuration. I'm capturing the initial install over capture card, hence these multicolour intermissions where a black screen would normally be seen. I've been struggling to recall the key to choose boot device. I can see F9 is the key to choose boot device. Given the choice to boot UEFI or non-UEFI, i.e. legacy, it's safe to assume that all modern hardware is going to prefer UEFI. I'm presented with these choices: try or install Ubuntu Server, or Ubuntu Server with HWE kernel. I don't want to try or anything. That reminds me of the live distributions, which I've wasted so much time trying to virtualize in preparation for this recording. When I chose try or install, it was because I had avoided having to learn what the HWE kernel actually was. I'll cover that mission briefly now. HWE is hardware enablement, or LTS enablement. It applies to LTS releases, which before rolling updates would have been stuck on the same kernel version for 2 years before the next LTS gave an opportunity for, originally, only a manual upgrade, i.e. downloading it and reinstalling it again. Since being automated, people still distrust the automated upgrade process. I, for one, would prefer to back up and restore to a fresh installation every 2 years. But LTS is supported for 5 years, so there's no hurry. What HWE does is provide kernels from non-LTS releases to the LTS distribution. Instead of waiting 2 years for new kernel features, the rolling upgrade period is 6 months. Does everyone trust it? I doubt it, judging by it being the second option, and I didn't choose it. You can change to the HWE path later on, but only with the server edition. It's not recommended to do that with the desktop edition. I've sped up the boot up log messages until we get to the installation questions. English UK. Update the installer to a non-LTS version. No thanks. Aside from the risk it would invalidate the distro source I already downloaded. Keyboard setup is fine. Choose the base, Ubuntu Server, or Ubuntu Server Minimal. I've set up Ubuntu on a lot of thin clients recently. I've got enough confidence to go with Minimal. Will still be offered important server software as part of the installation process. What is missing are some typical admin components, small, low-level packages that it can be tricky to locate to provide the core functionality. Ping, for example, will be offered in a choice of 2 packages when we inevitably decide we need it. Third-party drivers, or not? This machine is fairly thin already, the smallest of small desktop form factors. Somehow it came with Wi-Fi, but I don't need that as I want to efficiently wake on LAN and not pollute the radio spectrum. Here it has detected my networking options and I accept the defaults. No to proxy. Mirror address. I don't give that much thought, it's fine. Configure storage. Here it wants me to use LVM. LVM is an abstraction on disks. I'm economical in disk use. I'm still using a mechanical disk here. I don't want LVM. take this one disk and own it Ubuntu. I think Debian even defaults to LVM. In the past, I would have customized the partitioning. The EFI partition would get just 512 megabytes. That's all it needs. But what's 512 megabytes? More questions. At least with a GUI, I could expect and observe it to have already begun the installation process in the background. Never mind my name. You want to secure access here with a particular username, an obscure password. I just want to be done typing. Now to Ubuntu Pro. When I'm rich, maybe. Yes to open SSH server. Hard to believe we could continue without SSH access, but let's just be sure and tick yes. For a minimal server installation, these are certainly some sophisticated software packages we're being offered here. Prometheus is the only thing on the list I'm still meaning to gain exposure to. I've always felt it more suited to managing larger quantities of servers than I've had to date. I'm looking forward to exercising Prometheus on this homelab at some point. Installation proceeds unattended for 3.5 minutes, which I've sped up. It will reboot the login prompt. At this point I can remove the homelab from under my desk and work more comfortably from an SSH shell. An update and upgrade takes about 5 minutes, which I've sped up. This question about daemons using outdated libraries always surprises me. I notice there is no default, but hitting enter and nothing else progresses it. I'll reboot the whole system eventually. Now to find the image we want virtualized on this homelab. I Google Ubuntu Cloud Images and I'm looking for the releases. I've found the default location is dailies or daily releases, not actual releases. They're just the daily builds. They're not as safe as the releases. After finding the releases, I'm presented with all major versions ever released. I want 22.04, aka Jammy. Jammy sits in the middle of the list alphabetically, so instinctively I identify it by number instead. The latest release was on the 18th. Today is the 20th, and I've already seen a daily for the 19th. We do indeed have a release here, as the description in the right-hand column displays. More choice. Be careful. These are sorted by ABI. I want AMD64. The shortest named image is the largest to download. It is the master from which the others are derived. I was tempted by -disk-kvm.img. I thoroughly believed it was the right solution for running within KVM on an Ubuntu distro. Sadly, after many hours I realised that the cloud-init it contained was not accepting my configuration. I had to install libgestfs to grant me root access, or indeed any access. So I copy the link from here and wget it from the homelab. Now I use OpenSSL to hash my password with a salt of salt entropy 2000. The commands will be in the description below. I copy the output into the user data configuration. Also see the description below. I'll show this configuration in a minute. It's off screen, but it will be pasted in its final form into the terminal. First, let's generate an SSH key. Let's give it a description, and they will reply to all the questions it asks. Let's take a look at the directory structure that generated for us. .ssh. No authorized keys, but the key and public key with 600 and 644 permissions respectively. Cat the public key, copy it. Now let's paste it into that user data I was just talking about. No vim. I have to go ahead and install that now. Usual rubbish warnings about restarting service. I paste in the user data template. The name of our user is user1000. Sudo field configures our sudo as entry. Here we should be able to sudo without password. This long string is the hashed password just created. Shell needs specifying as bash, otherwise it will probably default to dash. We want our user to be in the users group and the admin group. Admin sounds a bit privileged, but we can refine it later. Authorized keys will contain the public key we just generated and that I just copied into Notepad. Save and quit Vim. Now for metadata. Here we just need the instance ID and hostname. These should be different per VM, but I often don't bother making that change. Individual IP addresses suffice to differentiate. The hostname has meaning to a VM. The instance ID is, I believe, used for internal referencing within cloud-init. I've tended toward remaining as ignorant of cloud-init configuration as possible. With a homelab I could investigate more, but these fields in user data and metadata are the essentials to get started quickly. I've hosted the public key that I generated on the homelab host in metadata too. I've got a feeling this should in fact be the public key associated with the guest. It's no use to me here in either case, so I don't test that hypothesis further. I'm going to need to install GenISO image to create a disk for cloud-init to read. I'll do that next and save it to /temp in common with a virtual hard disk. I'll reboot now to get rid of those nags to reboot multiple services. One problem with /temp is that it gets wiped every reboot. I repeat that last GenISO image command and copy the downloaded base image there also. Cloud images are particularly fast to provision, so if we don't care about what data we've got on there, it shouldn't make any difference, but eventually we will care, and that's why I've added a chapter onto the end of this after the one about installing Debian desktop by ISO. Now I create a virtual hard disk based off that download. It's /temp/ubuguest.qcal2 and 12GB should suffice. I can start a VM with this templatized virt-install command. Once you've seen these errors a few dozen times, they become easily recognizable. This is saying bridge BR0 doesn't exist. We need BR0 if we want to expose this VM onto the local area network. VirBR0 does exist, and I could substitute that for BR0, but VirBR0 doesn't have an IP address, and so would create VMs that weren't accessible outside the home lab. That's not what I want. It would be an excellent solution for a laptop. VirBR0 has its own private subnet, and whilst the VMs might not be accessible outside of that subnet, there's nothing stopping someone SSHing into the machine where they are available and accessing them through that machine. I copy the IPA listing. I don't want to publish my MAC address, but I do need to know the LAN address of the adapter I'm currently connecting through, and its name. To set up BR0 and have it remembered on reboot, I must configure it through the netplan configuration file shown. This file location varies depending on whether we're using desktop or server. More in the description. I need to be root to edit it. I paste the templatized version containing this homelab host's IP address followed by /24. The field is for plural addresses, and the BR0 interface will have access to this subnet. Gateway is deprecated and I find unimportant. Name servers can also be skipped. EN01 is the name of the interface currently in receipt of this IP address. I could use dynamic IP addresses here by replacing these three fields, addresses, gateway 4, and name servers, with the single field DHCP4:yes. It will mean my host gets a new IP address. There's a possibility of dropping the SSH connections when we come to apply it. Well, there's always that possibility when you're applying netplan configuration, but it's heightened when we're changing the IP address to a dynamically allocated one. We don't lose connection in this recording, but when you get adventurous, you're going to need physical or console access to the homelab device for when you do. Also, when experimenting, there's a ---- debug flag that I can sandwich between netplan and apply. This has worked. brctl show shows a new bridge associated with our physical interface, EN01. SDP enabled being no is entirely normal and acceptable here. I check what I have in /temp and reissue the virt-install command. It succeeds and the VM is now running. .myfaddr will not return an address now that we are using BR0. The addresses are managed by DHCP on the LAN. I connect to the console in time to see the end of the installation messages. Cloud-init is always the final part of the installation process. Log in using the user we configured in user data, user 1000. I'm in, and I have a new IP address on the LAN on ENP1SO 192.168.0.33. 52.54.00 F6 DD21 is the layer 2 MAC address. I cleared the screen for privacy concerns, but I checked my MAC addresses on the host and it differs to both the Wi-Fi and Ethernet adapters. I ping Google's DNS and it responds. We can connect outward at least. Now to test the opposite direction. I can SSH to the address. The address is exposed to the local area network, so it should make no difference, but this is only me connecting from the homelab hosting the VM. The homelab has its key on the guest. Before I can connect from my dev machine, I must enable password authentication in the guest's SSH deconfig. I restart SSH, which kicks me out, and I exit again to my dev machine. It accepted my password. Great, let's try another port. I find out what we're calling Python 3 here and launch its included HTTP server. I enter its address followed by port 8000 into my browser and see it respond. I try and display something more interesting, like my bash history, but it insists on downloading it instead. The server shows the requests. Everything is working. We can launch more VMs following this template. We just need to ensure that the file names in the temp directory are unique. Even the read-only cloud-init ISO will have become dedicated. It would be a pretty boring system if all we could install were Ubuntu cloud-init images. Well, no, cloud-init images are actually way faster to install than traditional ISOs. Think cattle, not pets. Let's mix things up a bit with a Debian desktop. We can install a desktop guest without the server even needing to have a GUI. I'll need to speed it up significantly as it spends over half an hour obtaining and installing the OS packages. This minimal, from the internet netinst ISO is about 1/10 of a DVD size. Debian used to come on multiple DVDs. With 400 megabytes downloaded, I copy it to /temp so virt-install has access to it. And I'll begin the installation as shown. No, not like that. That's using the default network, so will only be accessible to the homelab host, which has no GUI, and so would be pointless trying to access via a remote desktop. I abort, clean up, and repeat with BR0. Unlike with cloud images, there's no need to pre-allocate a virtual hard disk. So far, our cloud images have used the temp directory, which meant erasure and reboot. The alternative procedure, using the ISO, is slow, as we will show. So slow that Ubuntu don't readily support it anymore. I've added another section after this one on installing Debian Desktop by ISO. We will take what we learn about the ISO procedure and apply it to the cloud images to make them persistent. What we learn is that the virtual hard disk image we are creating goes in /file/lib/libvirt/images. For domain name and hostname are set on deb11. Root password makes an interesting offer if I do not set it. The offer includes granting my ordinary user sudo privileges. The ordinary user gets sudo privileges anyway in Ubuntu, so I'm tempted to stuff setting a password. I give in and set a password when in Rome. and create user 1000 here, as I did with Ubuntu. I let Debian guide disk allocation. Here the 1 GB second partition is for swap instead of EFI. With this netinst distro, a few more slow tasks must be run before we get to pick packages in tasksel. Tasksel is pivotal. I initially installed GNOME instead of XFCE because I'd had that work quite well with Ubuntu guests in the past. Too much changes with the Debian distro, and my first take attempting to use GNOME required heavy editing. I wasted a lot of time hastily applying patches from memory that might have worked better in Ubuntu than they do with Debian. It was getting hard to follow, so I created another VM from this point in the video. You can see the date gave from May 20th to May 22nd. I also renamed this new version Deb 11.2 instead of Deb 11. Here I dispense with installing GNOME. GNOME requires extra work to make work with XRDP. I would like to see any comparable positive before committing to that extra effort. XFCE works out of the box with XRDP. There are just a couple of minor changes required. Installation runs for half an hour unattended now. I'll squash that down to a minute. I don't want to reuse this terminal after the control character's ncurses is pumped into it. I reboot and catch it at the grub menu. Borders are missing and the screen state is reduced. I shelled into the homelab in a new terminal. Along the way I checked virsh, dom, if, addr for addresses. Of course there were none. The addressing being delegated to DHCP now. I had to make educated guesses as to what the new IP address was. I was going to have to use the console to check IPA. I got an error reminding me I already had a console. I returned to that console. Being stuck on grub, it's effectively barely got past BIOS. So I let that console go ahead and boot so that the SSH server would load. So my first guess was right after all that, 36. I find my user can't sudo in Debian, but I can su to become root. It says add user isn't installed. I need to su -l. Now my root user has a regular path and environment as are provided to regular users. Add user is back on the path. Now I can sudo. XRDP installs quickly and I take a little peek at my networking before attempting to RDP from Windows. Would you believe it is showing me a GUI in my first attempt? Look, I didn't get this second password prompt pop up when RDPing into GNOME on Ubuntu, but literature alerted me to it. Such is the well-trodden path of XRDP and XFCE. I re-enter the password, wondering what became of the first box I typed it into. After a long wait, this part isn't sped up. I get a desktop. Unlike my first attempt, when GNOME coexisted with XFCE, all the quick access icons are populated. Can I get a terminal? Yes. Can I launch a browser? Eventually, but it's Firefox no less. Can I get system monitoring tools? Which is what persuaded me to install Ubuntu Desktop in my first attempt at the homelab host. No, nothing matching that description here. I do have top, of course, which pretty much is as good as, a little clunkier. Look how frugal the whole VM is. A desktop OS inside 2 GB with room to browse the web. Let's demonstrate the effects of saving to temp on the Ubuntu guest we created first in this demonstration. I can't start the guest, and the error returned is that temp ubuntu guest ci data.isa doesn't exist. That's something of a surprise because the ISO I needed only at boot time. I thought I could discard it. So I'm going to need to persist that somewhere as well. I know from the Debian installation we just did that varlib libvirt-images contains persistent images. That directory is owned by root, so I'm going to sudo make dir varlib libvirt-images ubu-go1. There's going to be a different directory for each guest. That adds a fair bit of administration overhead, and it's probably a reason for starting with temp, especially if you're not going to need to restart, which I didn't think I would be restarting, because sleep is a very good substitute for restarting. I create another directory parallel to ubu-go1 called base, which is going to contain all the base images I download. At the moment, I just want to keep the non-KVM on. So I sudo cp the non-KVM on into varlib libvirt-images base. Now I gen ISO the data disk that cloud-init reads, permission denied. So I sudo gen ISO. Right, that worked. That's in our guests directory. Clear screen and create the virtual hard disk KVM image. And there's a permission error, permission denied, so I repeat with sudo, and that works. I can attempt the modified virt-install command now, where all the temp paths have been replaced with varlib libvirt-images ubu-go1. And the error I get from virt-install is that ubu-guest already exists. I get rid of existing entries in virsh with destroy and undefine. I didn't really need to destroy because it wasn't running. That just halts it forcefully. Undefine cleared up all traces of it from virsh's accounting system. Now I can repeat the virt-install. Now the name clash is out of the way. Okay, that worked. I'll do a virsh list and I see it's running. Let's get a console in there real quick. Catch all the boot up messages. Now that screen where it paused was interesting. You can see it's identified the gateway even though we haven't told it explicitly, so the gateway wasn't needed in the netplan. I write some random text to a file on the home directory of the guest just to prove that it's the same disk when I come to restart later. If we've got an Ubuntu targeted by the ubu guest identifier, then it will be the same disk. So this is largely a waste of time, but a stitch in time. Good save 9. I find the guest's Ethernet address, SSH in, check the file I just created there, and disconnect. Now to reboot the homelab host. Right, that's a physical machine with a hypervisor and a couple of VMs running on it, so it will need a little while to power cycle. I was going to say to boot up, but it's probably taking a little while to shut down the VMs too. Wait another few seconds and try again. Right, I'm back in. Let's clear the screen. Virsh list shows all the VMs are shut down. Uptime of 1 minute. Let's start ubu-guest. Let's try and get a shell to it. I guess the SSH server isn't working there yet. It shouldn't take very long to boot. Okay, there it is. The SSH server is running. It persisted.